The death of traditional databases. What's replacing them? Tired of wrestling with rigid schemas and slow queries? The database landscape is changing, and it's time to explore what's replacing the old guard. Let's dive into the future of data management. The world of data management is undergoing a massive transformation. The old ways are giving way to new technologies and approaches. Are you ready to explore the future? Traditional relational databases, RDBMS, like Oracle and MySQL, have been the workhorses of data storage for decades. They've served us well, but their limitations are becoming increasingly apparent. These limitations are especially noticeable in the face of modern application demands. The rise of big data and agile development is pushing the boundaries of what RDBMS can handle. A new generation of database technologies is emerging to address these challenges. These technologies offer greater flexibility, scalability, and performance. This signals a fundamental shift away from the traditional one-size-fits-all approach to data management. It's time to embrace the change and explore the possibilities. The exponential growth of data volume, velocity, and variety, the infamous 3 VERs, is a major driver of this change. Traditional databases struggle to keep up with this onslaught of information. RDBMS are particularly challenged by unstructured and semi-structured data. This type of data is becoming increasingly prevalent in modern applications. Think about social media feeds, sensor data from IoT devices, and multimedia files. These are all examples of unstructured data that don't fit neatly into relational tables. The rigid schemas and complex query languages of RDBMS create bottlenecks. This hinders performance and scalability, making it difficult to process large volumes of diverse data quickly. The need for agile development and rapid iteration is another crucial factor. Businesses need to adapt quickly to changing market conditions and customer demands. Databases must be able to adapt quickly to changing requirements. RDBMS often struggle to provide this level of adaptability, slowing down the development process. NoSQL databases are at the forefront of this data revolution. They offer a compelling alternative to traditional RDBMS. NoSQL stands for Not Only SQL, highlighting their departure from the relational model. They offer a more flexible and scalable approach to data management. NoSQL databases offer flexible data models that can accommodate unstructured and semi-structured data. This allows developers to work more efficiently with diverse data types. They also provide horizontal scalability, allowing you to easily add more servers to handle increasing workloads. This is crucial for applications that experience rapid growth. NoSQL databases are designed for high availability, ensuring that your data is always accessible. This is essential for mission-critical applications. NoSQL databases come in various flavors, each tailored to specific use cases. Understanding these different types is key to choosing the right database for your needs. Document databases, like MongoDB, excel at storing semi-structured data in JSON-like documents. This makes them ideal for content management systems and e-commerce applications. Key value stores, such as Redis, provide fast access to simple data structures. They are often used for caching, session management, and real-time analytics. Graph databases like Neo4j are optimized for managing relationships between data points. They are perfect for social networks, recommendation engines, and fraud detection. Columnar databases, such as Cassandra, are designed for large data sets and analytics. They are often used for data warehousing and business intelligence. Cloud-native databases offer scalability, elasticity, and cost-effectiveness. They are designed to run on cloud infrastructure. They leverage the infrastructure of cloud providers like AWS, Azure, and Google Cloud. This allows you to easily scale your database resources up or down as needed. Data warehouses and data lakes are also evolving to handle the increasing volume and complexity of analytical data. They provide a centralized repository for all your data. They often integrate with big data processing frameworks like Hadoop and Spark. This allows you to perform complex analytics on massive data sets. The death of traditional databases isn't a complete eradication. RDBMS still hold their ground in specific scenarios where data consistency and ACID properties are paramount. Data consistency and ACID, atomicity, consistency, isolation, durability properties are crucial for financial transactions and other critical applications. RDBMS are well suited for these use cases. The future of data management lies in a diverse ecosystem of technologies. This ecosystem adapts to the evolving needs of modern applications. This paradigm shift promises greater flexibility, scalability, and performance. Organizations can unlock the full potential of their data by embracing these new technologies. Ready to explore the world beyond traditional databases? Visit our website to learn more about NoSQL databases, cloud-native solutions, and the future of data management. Download our free white paper on choosing the right database for your next project and start building the future today.